What I have here is a direct current treadmill motor. This motor came out of an old treadmill, and you can read here on the specification plate. I know it's probably a little bit too small to see from this angle on the camera, but as you can see from the specification plate, I'll just read a few of the specs out to you. This is a DC motor. It is rated for 25.4 amps, 3,450 RPM, 130 volts DC. So, this motor is very interesting because it is a direct current motor. And unlike alternating current motors, which run directly off of the mains voltage that comes into your homes and businesses, this direct current motor has permanent magnets. A alternating current motor, that is an induction motor, has no permanent magnets. So when you get a motor that's this big and you take it out of a fan or perhaps a computer or something like that, and it's an alternating current motor, when you spin the shaft, you won't generate any electricity because there's no magnetic field to induce current in the coils of wire inside the motor. But this motor, being a direct current motor, even though it's really high voltage, we're talking 130 volts here, which is higher than the wall outlet power that you would get from a typical household outlet, which is 120 volts, this thing is still capable of generating quite a bit of power. Okay, so the first thing we're going to do is simply do a voltage test. I have here a standard multimeter. You can do DC voltage, AC voltage, amperage, etc. So I have the standard multimeter right here, and all I'm going to do is I'm just going to take these leads and I'm just going to connect them real fast to the multimeter, so you can kind of see here, just sticking them in there. The leads are pretty high quality, so I'm able to just basically stick the probes from the multimeter in there. I'm going to set the multimeter to 20 volts DC, so it'll register up to 20 volts of direct current. And then now that I've got the display going, I'm simply going to rotate the shaft. And you can see, even by rotating it just very lightly with my hand, I'm able to put out about 2 volts of direct current power. So that's very interesting. All I have to do is literally just turn the shaft ever so slightly, and I have no trouble getting, perhaps even as much as 3 volts out of this. And we need about 3 volts to light up a white LED. So now we're going to do a little bit more advanced of a test on this motor, and instead of spinning the shaft by hand, here now I have it hooked up to this cordless drill. And the voltmeter is still set to register direct current voltage, 0 to 20 volts. But this time, because we're spinning it with a motor, because we're spinning it with another motor, that is with the drill, we should be able to get some higher voltages out of it. So I'm going to test and just see how high we can get the voltage on this motor using this cordless drill. Okay, so I maxed out the 20 volt setting, so now let's go to the 200 volt setting, which will now enable us to register current or voltage between 0 and 200 volts. Now let's see how high we can push it. I would definitely call that test a success. Now we're going to do something just a little bit more interesting. So right here, I have a high voltage 100 watt LED. And when I say high voltage, I mean that it takes a rated voltage input of right around 33 volts to perform at its highest. So Because we just did a test on the ability of this cordless drill to spin the motor, it produced about 43 volts. I'm willing to bet that we can get likely enough voltage to make this LED glow pretty bright. This is a 100 watt chip, so the power output from this LED, or the light output I should say, is going to be very, very bright. I hope I don't damage my camera by doing this, but let's go ahead and just see. Can we light up this 33 volt LED using only a cordless drill and this treadmill motor? All right, we just proved it. Lighting up a very, very bright LED. That thing certainly had a lot of power. So to conclude this video, we showed the voltage output on a multimeter. We examined how this thing performed on a cordless drill, or hooked to a cordless drill, I should say. Then finally, we lit up a pretty darn bright LED with this motor. It can produce, again, about 43 volts when spun by this cordless drill right here. But if we're really looking at some uses for this motor, some more practical uses, a lot of people use these motors to construct hydropower or wind power projects. Because of how powerful these motors are, because of how much current they can put out, and because of just their versatility and their durability, a lot of times these things are used for wind power and hydropower projects where they're required to withstand a lot of stress. And because this motor, even though it has a really high RPM, again, 3,450 RPM, the rated voltage is 130 volts DC. So you don't even have to get up to 3450 in terms of the RPM to generate useful voltage. And in fact, this thing will generate 12 volts at just a speed of perhaps a couple hundred RPM. So you don't have to get it spinning that quickly to produce some seriously usable power out of this. And obviously, if you wanted to use it to power something even higher voltage, maybe you have a 24 volt system, a 48 volt system, for, say, wind power or hydropower, this would definitely be a very good motor for you. It's very powerful, it's very strong, it's very efficient. It's also very durable, and in addition, it's very heavy. In fact, it is really difficult for me to lift this thing up right off the table with the center of gravity being the way it is, because it is a very heavy motor. So that's a quick look here. It is a Macmillan Electric Company precision electric motor. It came out of an old Treadmill, and it's still alive and kicking today. Don't let the rust on the shaft fool you, because this is still very much a useful and very interesting motor.